All right, guys, we are back with part three of Descriptive Statistics lectures. Uh, Make sure you pay attention to this one because I really want to show you how each of the steps goes for calculating from start to finish the mean, median, the mode, variance, standard deviation, interquartile range, regular range, graphing the data, so you can see an example of all of these. Then go off and do it on your own. Do your homework. If you don't feel like you're getting it even after the homework, go practice more, right? You can find tons of examples of data online, or you can just look in the back of the chapter. There are always more examples for you to work on. Statistics is not like some other fields where you can simply look at it and always understand it right away. It takes a little bit more practice, and so you have to be the one that knows when you need more practice. I can't do that for you. I assign the homework as practice. Anything beyond that, it's up to you to sort of take it on and treat it like studying. Okay, so enough soapbox stuff. Let's walk through an example. So I was looking for cool data sets, and I found a website that had real data. And this one had the listing of nutritional content for a number of major fast food chain burgers. But it didn't actually list the names of any of these places. Probably good. So then I just Googled a bunch of random-ass names for burger places. Turns out there's actually a place called Burgatory. All the rest of these are just came from a website that helps you create restaurant names. So don't read anything into this. Don't go to, Burgopedia or Bergsurrection or Bergpeachment and think that there's actually going to be a place there that's the fat content of their burgers. All right, we don't want to slander any of these poor folks. But hypothetical data. Let's pretend it's fictional. We collected nutritional content about the primary burger offered at each of these particular burger joints. We're only really interested in the fat content. That's because we only want to look at one variable to make things simple for us. So here are the fat contents of the burgers of each of these places measured in grams. Right? You got a 19, 39, 35, 34, 43, 39, 31 grams. So what do we do with these data? Well, first, let's reorganize them from the lowest to the highest, right? It doesn't matter what the left-hand column says as long as you keep it paired with the right grams. We want this to be more easily seen in that right-hand column. And now once we have that, I don't really care what the burger joint is anyway, because this is all that we're going to be working with. These are our data. They range from 19 to 43. So let's go back to the very beginning of the descriptive stats lecture and work our way through each of the things we had to do. The first thing we did there was a frequency table. Lets us know how frequently each of these scores occurs. So remember, in a frequency table, you need to list all the values, even the ones that don't have any occurrence. So there wasn't actually a burger that had that fat content. I still have to list them all. So I've got 19 to 43 listed here. If I add in their frequencies based on that data, right, and so you can see it up here, there was 119, so I put a 1 there. Now there wasn't another score all the way to 31, so there's a whole bunch of zeros, and then a 1 and 31. The only score that occurred twice was a 39, so it's the only one over there that gets a 2. Right? And so now we have our frequency table. Pretty straightforward. Now remember, if you turn it on its side and you count that frequency as the height of the bars, then you can create your histogram. So the same data, frequency on the y-axis, our x-axis being the variable fat content in grams. Notice that there are no gaps between these bars except for in cases where there is a 0 frequency for that value. So at 34 to 35, you can see the slight white line, but those bars are there touching. That's because there's nothing in between 34 grams and 35 grams. So there's no reason to leave the bars separated like you would in a traditional bar graph. We can also then, of course, create a frequency polygon with these data, right? So a frequency polygon would look basically the same, but we'd replace the bars with lines, right? So you can see them again there. Remember, same data, just represented with lines and dots instead of with bars. Okay, so now let's work our way through the descriptive statistics. Let's calculate each of the measures of central tendency, each of the measures of variability. So these are the ones we need. These are the formulas that we need. All right, I went ahead and listed n off to the side. Remember, n is the number of scores in a population or sample. There are 7 raw scores here, 7 burger joints, and 7 burgers with their fat content. We next have the formula for the mean. Mu is equal to the sum of x divided by n. And then we see our formulas for both variance and standard deviation. And then at the bottom, I wrote down the formulas, although they're pretty straightforward, for range and for interquartile range. Okay, so let's start with the measures of central tendency. First, because it's the easiest, since we already have them organized like this, let's do the median. Okay, the median is the center point of scores. We have 7 total scores, so it's easy. It's that odd location, right? So we have 19, 31, and 34 on one side, 43, 39, and 39 on the other side, which leaves 35 right there in the middle. Our median is 35. Which of these scores is the most frequently occurring? Again, easy to identify because there's only 7 scores. The mode in this case is a 39. Okay, the mean. The mean requires a little bit more math. You have to add up all of those scores, which I already did for you. You can see that very last row says sigma equals 240. So the sum of those scores equals 240. So we take our formula, add 240 into the top, divide by 7 for our number of scores. We get 34.286, which, as I said, we report 2 decimals, 34.29. Okay, so the measures of central tendency are all really, really easy. Now, let's work on... In fact, before we move to variability, let me show you another example of how outliers can affect scores. So here's our data, right? N of 7, median of 35, mean of 34.29. What if I got rid of that score of 19, the one that looks like it might be a bit of an outlier? So I just delete it, okay? The animation's being a little weird there. So now I only have 6 scores. So if I were to recalculate everything, the median would now shift over here. The mean would then shift down as well, right? Or shift up, I should say. It goes up by 2.4 grams. That's a reasonable jump when we're only talking about a scale of about 40 or 50 grams. What if, instead of that, I entered in a fat-free burger? Right, so now I'm back up to an N of 7. Our median's back into the same location, but notice our mean drops by 3.5, 3.6 or 7. Right, my point is that the mean is sensitive to extreme scores. The median is not. The median stays relatively consistent, okay? So in situations where you have outliers, when it's your own data, you may feel as though it's necessary to report the median and the mean so people have a better idea of that. In case you're looking at that big, long German word, Gedanken experiment, it just means a thought experiment. So what if, right? And that's what we're doing here. What if this happened? What if that happened? Okay, so measures of variability. The bigger ones are the variance and standard deviation in terms of the number of calculations that you're going to make, so we might as well start there. Remember, we're going to take this through with the order of operations, so we start with P for please excuse my dear Aunt Sally, P for parentheses. So let's just start there with the standard deviation formula that's right there in the middle of all of that information, the one with the square root above it. Start inside of the parentheses, right, starting with P. X is the raw score minus mu, the mean for that population. Do that for each of those scores. That's first. Do everything in P. So we create a new column to the side here. We're going to label it as X minus mu, X minus the mean. And for each cell, we're going to fill in that value for X that's on the left minus the mean that we have down below, that 34.29. So we'll start out with 19 minus 34.29 to give us a negative 15.29. Do this the whole way through. Right, all the way down to 43 minus 34.29, giving us the 8.71. Okay, what's the next step in the order of operations? It's the E, the exponents. So in this case, the exponent in this formula would be the squaring of everything that was in parentheses. So we now need to square each of these values. This is good because this is where I said it takes away the negatives. Okay, so make sure, because some calculators are weird, you'll type in negative 15.29, then hit squared, and it'll tell you a negative number as the output. You have to know your own calculator and remember that you never have a negative square, right? When you have squared a number, it becomes positive in every single case. Okay, so square all of those values. We get 233.78 all the way down to 75.86. Now remember, the next step here is to sum all of those values, right? So this is kind of like applying a multiplication type function to the parentheses. We're still working on that parentheses as well. So sum all of those values together. Everything in that last column gets added up. And you should end up with something around a 365.4, okay? Divide that then by the n that's in the denominator of that formula, right? An n of 7, because it's 7 scores, and we have our variance, right? Our variance is equal to 52.2. Now remember, the last step in standard deviation is to take the square root of that. So we take the square root of 52.2, we get a standard deviation of 7.22. So on average, each individual score differs from the mean by about 7 points. Okay, so the mean of 34. These scores differ by about 7 in both directions. Okay? The last ones that we need to calculate then are simply the range and the interquartile range. So the range is easy. Remember the highest score minus the lowest score. So 43 minus 19. The range is 24. For interquartile range, first let's remember we have to identify where the second quartile is. That's right. Quartile 2, the median, was right there, was 35. So I'm going to scratch it out, and now we're going to look towards the top and the bottom sets. So quartile 1 and quartile 3 are the center points of each of those two groups of numbers. So that group of 3 at the top, the center there would be 31, quartile 1. The bottom, the center there would be 39, quartile 3. And so our IQR, our interquartile range, is 39 minus 31. So our interquartile range is an 8. Okay, so like I said, that was kind of a quick rundown because I can't actually do calculations on PowerPoint. I have to show you the steps more sort of all at once. But hopefully that made sense. Now go practice it. Go find some data, work on it. Very, very shortly, all of these data will be in the homework assignment as soon as everyone's filled out that Google spreadsheet. So you can go ahead and get started on that as well using our actual class data. Practice, practice, practice. It's really easy once you've learned how to do it. All right? Cheers.